Hello, welcome to this lesson on how to solve the center of mass of a triangle lamina. Okay, so if you've not subscribed to my channel yet, kindly subscribe for more video and to support the channel as well. Alright, let's go through the question together. So we are supposed to find the center of mass of this triangle lamina, given that the density of the triangle lamina is this. Okay, so how do I go about this? Alright, one thing that you should know is that for a triangle lamina, if let's say this is a triangle lamina, okay, here, if there is a triangle lamina, the center of mass, if let's say this is a uniform, okay, it wasn't drawn into scale, so kindly forgive me, then the center will be located at the exact center of this triangle, the center of mass. Okay, so how do I solve this question? It means that since the height is given, let's say this is h, okay, then the center of mass will be some part of the h. Okay, so it has to be h 2h. It can't be 2h because it can't be more than the h. So you see that half h, 1/5h, something like that. It should be some part of the height. Okay, that is what we know. We know the base and the height, but there is no way the center of mass will be located on this base here. Okay, so it has to be on this line. If that is the case, then let's try to put the center of the triangle lamina on a Cartesian plane. Okay, alright, so let's do that quickly and see how you go about the question. Okay, alright, so given the triangle lamina is like this, okay, this is a triangle lamina. Okay, now if I draw the y-axis through the height and the x-axis through this part, okay, so it becomes like this. Now here is my x, then here will be my y-axis. Okay, let's look at this. That this is what 90 degrees, but the whole of this side is the h, and here is what the r/2 given in the question. Okay, so here is our height h, small h. Let's call it capital H in the question so that we go by whatever that is given. Okay, so capital H like that. Now what are we up to? One thing that we can do is that we should always know that there is a point on this height, okay, that our center of mass will be located. Mind you, in our last video I made mention that the center of mass is actually measuring a distance or a length on something, okay, that we think that this will be the the part where the mass will be concentrated at. Okay, so that when you put this triangle lamina on a sharp edge, it will be at equilibrium. Okay, now with this idea, it means that at this point where you want to find, there is the x coordinate is what 0 and there's some y coordinate. So our main problem is to find the y coordinate, where the y coordinate will be what our YCM. Okay, but if you know that it's a continuous sum, okay, YCM is actually summation something, but this time it's a continuous sum, so you are going to use the integral formula. Okay, now if you have to write our center of mass formula back, okay, let me write it back for you. One thing that we should know that since it is only on the y coordinate or the y axis, it means that we'll be in one dimension. Okay, so you know the YCM is always given by an integral of y times lambda dA, okay, over integral of lambda dA, or sometimes it is sigma. Since in this question we're being given what sigma, so let's use sigma rather. The lambda is the density, so here if the density is given us what the sigma, then forgive me about my sigma. Okay, so that is it, that is the formula that we should use. But now the question is, what is my dA, what is my sigma? Because sigma is given in terms of x and y, and we don't have any x and y in this integral. Okay, if you remember, we said that in a y or a 1D or in a 2D, this diagram here is simply a triangle. Okay, so we said that lambda or sigma is giving us what dm over dA. So this a or dv, let's say dv, the volume, okay, where the volume will be the space occupied by the object, and now the space occupied by this whole triangle lamina will be an area. Okay, that is why I said the dA. Okay, in 1D it will be just a length. Okay, but this case that we are dealing with, it is in 1D, that is only on the y-axis. So how do I go about this? Someone will say we should start just writing the dy and go. No, because we should find the dA means that there are some continuous sum of some small areas, okay, which will give us the total area of this triangle. I hope you get it. So we should find you can calibrate the triangle into some small portions. Okay, if you are able to do that, then you'll be able to find our dA. Okay, I hope you get it now. Alright, so since you've been able to calibrate this into the Cartesian plane and known that the center of mass will be on the y-axis, since we are drawing the Cartesian plane along the center of the triangle lamina, let's come back and calibrate our triangle lamina into small portions of areas. Okay, alright, so given this, we know that the triangle lamina is what, like this. Okay, just like this. Alright, so with this, let's try to find an expression for this sigma here. Okay, and you know this is the y-axis. If you remember, that is what we said. Okay, let's say if this is my y, okay, and this will be my x-axis. Okay, but here to here, let me calibrate it well so that you see what I'm coming to write. Okay, this is my y-axis. Okay, but here to here is what h, that is our height, and here to here is what r/2. Okay, now this is what this is a right angle triangle. Okay, so we can use the Pythagoras theorem to write an expression for x and y. Okay, if I call this side p as the hypotenuse, then p squared is equal to s squared plus y squared. I hope you get it. This is my x and this is my y-axis, so y squared plus s squared is our p squared. I hope you get it. It means that on the x-axis, every x that I pick, I square it, and on the y-axis, every y that I pick, okay, provided that the length here from this side to this side is our hypotenuse, we will get p squared. Okay, I hope you get it now. Now on this right angle triangle that we picked here, this side, this right angle triangle that we picked, what is our y value there? Or let's check this. Okay, from this equation, what can you say? You could see that that's the same expression for our density. Okay, so it means our density is also the same as p squared, which is what, s squared plus y squared. It means that for every s value that I pick and y value that I pick, if I square them and I add them, I will get my density back. Okay, now what is the highest value of y here? If on this right angle triangle, if I pick it out like this, okay, here to here is what, our height, and here to here is what, our r/2. Okay, and so this means that our x here, in order to find our p squared, which is s squared plus y squared, the same as what, our density, our x is equal to what, r/2, and our y is equal to what, h. I hope you get it now. So it means if I substitute these values of x and y inside, I'll get my density. Okay, so let's put that in and find our density before we come and calibrate and get our dA. Okay, so now the density formula is given by this, but in effect is the same as the hypotenuse squared. Okay, and we are saying that for when x equals r/2, our y is equal to what, h, from the right angle triangle that we got from the triangle lamina. Okay, so it means that our density, which is s squared plus y squared, is actually s squared, which is r/2 squared plus y squared, which is h squared. Okay, and this will give me r squared over 4 plus h squared. So this is our density in effect. Okay, so we are done with the density. It's left with our dA. Okay, so we can quickly come and put it somewhere here. Okay, all right. So now, knowing our density to be r squared over 4 plus h squared like this, let's try to find our dA. Now if I pick the triangle lamina like that, okay, and now if I try to calibrate it like this, okay, into some small portion of rectangle, okay, I hope you can see that this is a small portion of rectangle, okay, and this is my height, okay, and this is the whole of this side from here to here is r, okay, because half of it is r over 2. Okay, now in this, for the small portion of rectangle that I took, okay, this straight line will be a small change in y, which will be what? dy. Okay, so if I call this point E, then let's say A, okay, let's say I call here to be C, B, let's say Q here, okay, and this junction, okay, if I call this junction from here to here, from here to here, okay, let's call this junction, let's say T, okay, alright, but on the y-axis we are assuming that we are doing all of these on the Cartesian plane. So on the y-axis from here to here is a change, like some y that we don't know, okay, I'm just calibrating it from our basic idea that we know, because you have to get a formula that we can write for the dA, okay. Then this means that the area for the small rectangle that we're able to take from this triangle lamina will give us a small area, okay. This dA actually means a small area, and it's equal to the length, for a rectangle. This rectangle that I've taken here, I'm coming to label it as it is in the diagram, okay. So like I said, on this diagram, this side to this end is what? E to A. I hope you get it now. I hope that is cool. Alright, and then a small change in the side of the rectangle, that is the vertical height, is what? dy. It changed with respect to what? Y. So like I said, if this side, the ends is E to A, right? So the small area of this rectangle, okay, compared to the area of the rectangle, compared to the whole area of the triangle lamina, is very small. That is why we are calling the dA. Okay, it's equal to rectangle. The area of a rectangle is what? Length times breadth. Okay, so EA, the length EA times dy. Okay, I hope you get it now. Now, if it is EA times dy, then what is that EA? Okay, so from the idea of similar figures, okay, or similar diagrams or planes, okay, what you know is that if I say that the length here from E to A in the triangle lamina, if I divide that by the length QB, okay, it should give me the same length if I move from C to T, okay, CT over the whole of, let's say I call here, let's say W, okay, the whole of CW. I hope you get it. It's like the shorter one over the longer one. So in this triangle lamina, this side, okay, we've been calibrated it into EA, which is shorter than the QB, okay. This over that should give me C to T, this C from this side to this side, T, okay, this side, over the same length C to the W, which is the longer height, okay. And now this will give me what? EA, we don't know, okay, but C to T is what? That one too, we don't know, okay, but the whole CW is what? RH, and QB is what? RR, okay. So I can put them back in it, okay. Let me erase some parts and we'll do this there, okay. Hello. So like I said, you have E over A, over QB. QB is what? Our total base, which is R, okay? And this is equal to CT. Our C to T, we don't know, okay? But we'll write an expression for it very soon, just wait. But our CW is the whole height, okay, H. And we named T to W, okay, this part. Let me use another color for you to see. We name this part from this to this part, okay? We name this part what? Y. It's a change in Y, so we don't know. So it's a Y that we don't know, okay? So this, from this part, okay, to this part, we said it was what? Some change in Y, okay? I hope you get it now. So if that is the case, then the whole of this length will be what? C to T. We have T here and we have W here, okay? But C here to T here is like this. Let me write it somewhere here so that you can see clearly. It's like this one. This is how it is, and we've calibrated that from here to some part is what? T, okay? And from this T to here is W, okay? So by we name this part that everything is changing with respect to what? Y. So from here to Y, here will be a certain Y value that we don't know, okay? Then from this whole C to W is what? RH. So if you want only this side, C to T is H minus Y, okay? So if you want what is between here and here, it's just the whole of this height, which is H, minus this Y, okay? This small portion that will give us this portion. I hope you get it. So we get our CT to be H minus Y, okay? Now we are good to go. This will imply that our EA is equal to R into bracket H minus Y, okay? H minus Y, okay, over H. I hope you get it now. So that is our EA. But if you remember, we said that our DA is equal to EA times DY, this one. So we come and put our DA, which implies that the whole of EA, which is R times H minus Y over H, will multiply our DY, okay? So let's write that quickly and start solving, okay? This means that our DA is actually equal to what? EA, which is what? R into H minus Y over H times dy. This is true because we said the change or the length of the center of mass should be located on the y-axis, and indeed everything has been changed to the y. It means we have to do everything in terms of y, okay? Mind you, I said that the final answer is supposed to be something h or h over something, because if you look at it clearly, the center of mass will be located at the center, and then on the center it should be located on the height, because the height is through the center. Okay, I hope you get it now. All right, let's do something, erase everything and start calculating. Okay, so knowing all these, we've been able to find our sigma, which is the density, and it's s squared plus y squared, and in effect is the same as r squared over 4 plus h squared. And we know our dA to be like that. Okay, now our YCM will be equal to the integral, now the limit of y. Okay, I forgot to say that, but if you can see from the triangle lamina that we drew, it was this, and this was the origin. Okay, and this was our x-axis, this is our y-axis. Now the highest length for this triangle lamina is what? H, from 0 to what? H. Okay, so the y will range from 0 to h. Okay, I hope you get it. Alright, so this is equal to integral from 0 to h. Since the y ranges from 0 to h, then y is what? Just y, and sigma is what? R squared. Okay, the reason why we are writing sigma in terms of r and h is for every x and y that we know, if you know x to be this and y to be this, if you put them in this equation, you should get our sigma. And at that point we said that maximum y will be what, h, and the maximum x, depending on the right angle triangle that we drew, was r over 2. Okay, so if you square them, we'll get what's our sigma, which is our density. Now we have that, then the a is what, r into h minus y over h dy. Okay, so all of this over integral of sigma is what, r squared over 4 plus h squared, okay, times r into h minus y over h dy. I hope you get it. Now I can factor some things out because we are integrating with respect to y, but r and h, they don't depend on y, so this whole ycm can be also rewritten as what, the top side I'm factoring r squared over 4 plus h squared. They are all in a bracket, so I can factor them out. The integral from 0 to this one too, from 0 to h, 0 to h, okay, then y, then r over h. This side, this bracket, I'm factoring y over h out, then h minus y dy, then over the same thing will come out, r squared over 4 plus h squared out, okay, then integral from 0 to h, r over h, okay, times h minus y dy. Okay, so r squared over 4 plus h squared can cancel this one at the top here because they are dividing. Now I'll be left with what, let's come and write everything at the right side. Okay, since I've been able to write this like that, then this will be equal to integral from 0 to h, okay, the ycm, y times r over h. Okay, let me write it well because I can also factor something out, so I'm just writing the word so that you see it. So since multiplication is commutative, I can write it like this: y into h minus y dy over integral from 0 to h, r over h minus y dy. Now r over h is also a constant, so I can factor that one out from the top and down, and so this will take this out. I hope you can see it, or you can do it systematically when you are writing it by yourself, or when you are going through it by yourself. Okay, so now I'm writing at the top here. This will be equal to integral from 0 to h, then what we have is what, y times this bracket, and that will be what, yh minus y squared all dy, the integral from 0 to h minus y all dy. Okay, so this integral has become very simple for us. Okay, let's continue to the right side and solve it. Okay, so now this is equal to, when I integrate yh with respect to y, I get what, 1 over 2 y squared h, okay, and from 0 to what, h, then minus, when I integrate y squared with respect to y, I get 1 over 3 y cubed from 0 to what, h, all over, I integrate the down part, I get hy from 0 to what, h, minus what, 1 over 2 y squared from 0 to what, h. I hope you get it. Now this whole thing is equal to, the numerator will give me what, half h cubed, because when I put h in place of y, I'll get h squared, then times h, I'll get h cubed. When I put 0 in, I'll get 0, so I don't bother myself. So I get half h cubed, then minus 1/3 h cubed, okay, at the top, over the down part, I'll get h squared minus half h squared, okay. Now half h cube minus 1/3 h cube. Okay, this is the same as 3h cube minus 2h squared, the top one, all over 2 times 3, which is 6. That is the numerator, divided by the denominator is h squared minus half h squared, means 1 minus half. That will give me what? Half h squared. Okay, let me write it well for you. Okay, half h squared. Okay, now this side, the first term will give me 3h cube minus this. I'll get what? Just 1, so I'll get h cube over 6 divided by h squared over 2. This is the same as h cube over 6 times 2 over h squared. Okay, and so what will be our final answer? Let me write it in the middle here. Okay, I'm coming to use a red pen to write it. Okay, now our final answer will be h cube. This is h cube. Okay, and the down part is h squared, so we get h. Okay, now this is 2, it goes into itself 1 and goes with 6 or 3, so I'll get h over what? 3. This is our YCM, and so it means that this will be our center of mass, because we said the s component is not part, because the center of mass should be located on the height. Okay, because imagine if I have a triangle like this, okay, and I'm saying the center of mass, it means the center is here. This is the center, so on this height, which part is it located? So if I draw a Cartesian coordinate along this, it means the s coordinate at that point will be 0, so we just look for the YCM, which will be our RCM. So in effect, our RCM is equal to what? H, the height given, over 3. This is the solution to the question given. Okay, so thank you, and don't forget to subscribe to my channel if you haven't.